Now, this has a lot of definitions, collecting and gathering data, and it starts by discussing the difference between experiments and observational studies. Now, experiments, you're assigning subjects different types of either treatments or factors and levels, which we're going to be discussing in a bit. So, for example, if I want to take, say, 90 vehicles, and I'm going to assign 30 of them tire A, 30 tire B, and 30 tire C, and see how long they last, that would be an experiment because I'm actually assigning those vehicles tires. Versus an observational study, I'm just going to observe. I'm not going to do anything. I'm just going to see what is already on the vehicles and what tires they have and see how long they last. So I didn't do anything. I'm just seeing what happens naturally. Now, within observational studies, there's a few different types. Cross-sectional studies is a snapshot at a current time. So an example of that would be, who would you vote for right now in an election? At this instance in time, that's a cross-sectional study. A lot of times that's when polls come out for that instance in time. Case controls known as retrospective studies. Retrospective is in the past. So going back to the tire example, we could go and see what tires were on which vehicles and how long they lasted. That would be a retrospective case control study. Prospective looks forward. So it says, okay, let's see who just got these tires and see how long they last, and we follow them over maybe a 6-month period. Being able to tell the difference between experiments and observational studies and those other types of studies are common questions that may be asked. And then from there, you're going to be seeing considerations when you're sampling, like what do you have to worry about? And the three main ones are going to be controlling variability, randomization, and replication. Now, as far as controlling variability, you could use a placebo. A placebo is like a water pill, a dummy pill, or basically a group that gets nothing, like a control group. A control group a lot of times will get a placebo. So if like you're doing headache medication, maybe one group gets a water pill, the other group gets the medicine. The group that gets the water pill, that's the control group, and they receive the placebo. Blind means the participants don't know which pill they're getting. Double-blind means the participants don't know, and the researchers don't know. There's a third party out there that will tell them later. And the reason why double-blind is good is because the researchers, if they knew who was getting what, they might bias the results. We want to randomize as much as possible. That way everything is fair and treated equally, which we're going to be talking about in just a minute. Replications, the word replication I don't really like. Replication just basically means like how many subjects in each treatment group. Okay? Like if I had 2 medicines, I wouldn't just get 2 people. Person 1 gets medicine A, person 2 gets medicine B, and compare. That's not enough. I'd want like 30 people in one group and 30 people in another group, and then compare based off of the overall average between them. So that's what we deal with replication, how many times or how many subjects are in each treatment group. And speaking of each group, a matched pair is when you actually have 2 groups and you want to try and match them as much as possible. Twins are usually a good example where you're trying to compare, twin 1 to twin 2, but that's not always the case. A block design extends that to 3 or more groups that you're trying to go ahead and do some comparative analysis. Now, with sampling, again, lots of definitions. Ideally, you want what's called an SRS, which is a simple random sample. Everybody has an equal chance of being selected. A lot of times it's done on a computer, but that's the goal, is we want an SRS, a simple random sample. However, a lot of times we get what's called bias, where it tends to lean toward one or the other. And examples that occur here are what's called a volunteer sample, where a volunteer sample or a convenience sample are not the best ways, because what will happen is, for example, a volunteer sample is like maybe an internet poll, where not everyone has internet and people may answer multiple times. So that's not a good sample. It systematically favors certain outcomes, is what they say. They're not representative of the population of interest. A convenience sample is like a survey done maybe like at the food court, okay, where it's done in a convenient way, or maybe it's done just in class real quickly. And the different biases that occur that you might be asked are the following. Under coverage, not everyone is represented. So for example, for that volunteer sample, if you do, let's say, an internet poll, well, those that don't have internet or don't have access at that point in time would not be represented fairly or equally. Non-response is when they're just not willing to respond. Think of end of semester surveys or feedback. There's usually a large non-response bias. You're just not responding. Response bias is the answers are altered. You may lie, you may bend the truth, you may say something differently depending on how it's presented to you. And then, of course, the wording of the question may be subjective. A good example would be, I'm doing a good job, aren't I? Which I'm trying to get you to say yes. With all this, we want to be as accurate as possible, and the way to measure accuracy is by what's called the margin of error. And the formula for that, which you need to know, is 1 over the square root of n, where n is the sample size that you've actually taken. Lastly, when dealing with experiments, you have to worry about what's called factors, levels, treatments, replications, and the response. This is a very common set of questions that's asked that you need to know about. So let's do some examples of these. Factors are the explanatory variables, the inputs, and levels will be the different parts of the factor that you might encounter. Treatments is the combination of factors and levels, and when it's only one factor, levels and treatments are the same. When it's more than one factor, it's the actual multiplication of the different levels. And what I just said, I'm going to do with these two examples below. Replications is the sample size over the treatment groups. That's a formula that you need to know. And the response is the outcome. So for example, does headache medicine relieve a headache? 0, 100, and 200 milligrams was divided equally amongst 30 patients to see how long it would take for the headache to go away. So as far as the factor here, the factor in this case would be, well, the input, it'd be the headache medicine. Headache medicine. So there's one factor. And then the levels, well, there's 3 levels overall, 0 milligrams, 100 milligrams, and 200 milligrams. As far as how many treatment groups we have, well, whenever you have one factor, it's going to be the same levels and treatments. There's 3 treatment groups, 100, 200, and of course, 0. And then replications is going to be the total sample size, 30 patients, divided by the number of treatment groups is 10 in each group. And lastly, what are we trying to do? What's the response? It's the time for the headache to go away. Boom, boom. And there you go for this example. For this next one, I'll answer these questions up here. And I'll use the following. Does headache medicine and sleep relieve a headache? 0, 100, 200 milligram dosages were given along with no sleep and a 30-minute nap. These treatments were divided equally amongst 30 patients to see how long it would take for a headache to go away. So the factors, there's 2 of them. It's going to be the medicine, and it's going to be how much sleep they get. Levels, well, you wouldn't say how many levels there are total. You would just say that factor 1 for medicine, there are 3 levels, 0, 100, and 200, and for sleep, there are 2 levels. Now for treatments, 3 times 2 is going to be 6. Why are there 6 treatments? It's all the combinations overall, okay? What are those combinations? Well, if you think about it, it would basically be 0 milligrams with no sleep, 0 milligrams, 30-minute nap, 100 milligrams, no sleep, 100 milligrams, 30-minute nap, 200 milligrams, no sleep, 200 milligrams, 30-minute nap. All the combinations, which means you multiply. Now from there, as far as number of replications, well, we have 30 patients divided amongst 6 treatment groups, means we're going to get 5 in each group. And the response, once again, is the time for the headache to go away. So between identifying the different factors, levels, treatments, replications, responses, knowing the different types of ways to have biases and samples, the considerations with sampling, and then initially, experiments and observational studies is a lot of definitions that you need to know examples of.